नमस्कार. इयत्ता 9वीच्या विद्यार्थी मित्रमैत्रिणींनो, आजच्या विज्ञान 1 विषयाच्या या ऑनलाईन क्लासमध्ये मी आपलं सर्वांचं हार्दिक स्वागत करतो. विद्यार्थी मित्रांनो, मागच्याच तासांना आपण विज्ञान 1च्या चौथ्या धड्याला सुरुवात केली होती, ज्याचं नाव आहे मेजरमेंट ऑफ मॅटर. आणि यामध्ये आपण लॉज ऑफ केमिकल कॉम्बिनेशन्स पाहिले होते आणि त्यापैकी आपण पहिला लॉ पाहिला होता, त्याचं नाव होतं लॉ ऑफ कन्झर्वेशन ऑफ मॅटर. त्यानंतर आपण दुसरा लॉ पाहिला होता, लॉ ऑफ कॉन्स्टंट प्रोपोर्शन, which state that the proportion by weight of constituent element in the various samples of a compound is fixed. Now we are going to verify this law. यावेळेस आपण हा जो लॉ ऑफ कॉन्स्टंट प्रोपोर्शन आहे त्याचं व्हेरिफिकेशन कसं करता येईल काही एक्झाम्पल घेऊन ते आपण पाहणार आहोत. तुमच्या पुस्तकामध्ये सुद्धा पान नंबर 48 वरती हे उदाहरणं दिलेली आहेत, ज्याच्या सहाय्याने या नियमाची पडताळणी या ठिकाणी आपल्याला करून पाहता येते. मेनी कंपाऊंड्स कॅन बी मेड बाय द डिफरंट मेथड्स. म्हणजे आपण रसायनशास्त्रामध्ये अनेक प्रकारची संयुग ही वेगवेगळ्या पद्धतीने तयार करू शकतो. म्हणजे एकच प्रकारचा संयुग आपल्याला 2-3 पद्धतींनी मिळवता येतं. फॉर एक्झाम्पल, लेट अस टेक द एक्झाम्पल ऑफ कॉपर ऑक्साइड. दिस कॉपर ऑक्साइड कॅन बी ऑब्टेन बाय two different compounds and two different ways. So first way is we can obtain it by the decomposition of CuCO3. We get CuO, copper oxide, from the decomposition of CuCO3. म्हणजेच काय तर कॉपर कार्बोनेटचं डिकम्पोजिशन केलं असता आपल्याला हा प्रोडक्ट मिळू शकतो, कॉपर ऑक्साइड. दुसऱ्या प्रकारे सुद्धा आपल्याला मिळवता येतो तो कॉपर नायट्रेटच्या डिकम्पोजिशनने सुद्धा तो आपल्याला मिळवता येतो. कॉपर नायट्रेट CuNO3 याच्या डिकम्पोजिशनने सुद्धा आपल्याला हा CuO म्हणजेच कॉपर ऑक्साइड हा मिळवता येतो. फ्रॉम ईच ऑफ दीज सॅम्पल्स a mass of 8 gram of copper oxide can be prepared. या दोघही प्रकारे आपल्याला 8 ग्रॅम कॉपर ऑक्साइड या ठिकाणी मिळवता येतो. सो इफ दिस कॉपर ऑक्साइड इज ट्रीटेड सायमल्टेनियसली विथ द हायड्रोजन, then we get two types of product. One is water H2O and another is copper. If we treat this copper oxide with hydrogen, जर या कॉपर ऑक्साइडची अभिक्रिया आपण हायड्रोजन सोबत केली तर यांच्यापासून आपल्याला प्रोडक्ट्स मिळतात H2O which is water and also we get copper. This is compound and this is element. This copper oxide is 8 gram. And in this 8 gram copper oxide we get 6.4 gram of copper and also we get 1.8 gram of water. Both gave us 6.4 gram of copper and 1.8 gram of water. Let us see how this is a verification of the law of the constant proportion. The reaction of copper oxide with hydrogen yielded two known substances, namely water and copper. In this, water is the compound which is made from hydrogen and oxygen, and we know hydrogen oxygen are in the proportion 1:8 in the water. Suppose there is a 9 part of water is prepared. In this 9 part of water there is a 8 part of oxygen and 1 part of the hydrogen. So we know that in 9 gram of water there is a 8 gram of oxygen and 1 gram of the hydrogen is present. So in this way we can calculate in the 1.8 gram of water how much oxygen is there. So how we can calculate it? We can calculate by simple method. 8 multiplied by 1.8 upon 9. is equal to 1.6 gram of oxygen. This shows that 1.6 gram of oxygen is present in the 1.8 gram of the water. So let us find out the composition of copper and oxygen in the copper oxide. In this copper oxide we get 6.4 gram of copper, and just now we have calculated there is a 1.6 gram of the oxygen. So we can get the proportion by weight of copper and oxygen. How? We can divide them by 1.6. So if we divide this by 1.6, we get 4, and here we get 1. 4 as to 1. So this is the proportion by weight of the copper and oxygen. So this means the law of constant proportion is verified here. In another example, we can verify this law by knowing the weight. Let us see how we can calculate it by knowing the molecular formula of copper oxide. In copper oxide, there is a copper and oxygen are present. So the atomic masses of copper is 63.5 and atomic mass of the oxygen is 16. This means that by proportion by weight, the 63.5 gram of copper is present in copper oxide and 16 gram of oxygen is present in the copper oxide. If we divide them by 16, जर आपण यांना दोघांना 16 ने भाग दिला, we get the numbers 3.968 and here we get 1. So this is very close to 4. 3.968 is very close to 4. We can write it as a 4, and here 4 as to 1. So here also this law is proved by taking the atomic masses of copper and oxide. So this is the verification of law of constant proportion we have done by taking the example of copper oxide. Now let us see the next topic, which is atom, its size, mass and its valency. So students, next topic is atom, its size, mass and valency. म्हणजे अणु, त्याचा आकार, त्याचं वस्तुमान आणि त्यावरून ठरणारी संयोजन. So in the last year, in the 8th standard, you have also learned about the atom, and also you have learned different atomic theories which are put forward by different scientists. वेगवेगळ्या शास्त्रज्ञांनी अणुच्या संरचनेबद्दल काही theories मांडलेल्या होत्या. त्या आपण मागच्या वर्षी इनसाइड द एटम या धड्यामध्ये 8वी मध्ये ऑलरेडी शिकलेलो आहोत. मग तुम्हाला या ठिकाणी दोन प्रश्न विचार डिपेंड ऑन युअर प्रिव्हियस नॉलेज. तुमच्या मागच्या ज्ञानावर आधारित आहे. फर्स्ट क्वेश्चन इज, फ्रॉम विच एक्सपेरिमेंट्स वॉज इट डिस्कवर्ड द atoms have an internal structure and when? अणुला अंतर्गत संरचना असते हे कोणत्या प्रयोगावरून ठरलं आणि केव्हा ठरलं? तर हा जो मुद्दा आहे हा आपला ऑलरेडी मागच्या वर्षी झालेला आहे. तुम्हाला आठवत असेल, इन 1897 सर J.J. Thomson, he was the scientist who put the atomic structure theory. याने अणुच्या संरचनेबद्दल त्याची थेअरी मांडली होती. ही स्टडीड द कॅथोड रेज इन डिटेल्स. त्याने कॅथोड रेजचा प्रयोग केला आणि त्या ठिकाणी त्याने थेअरी मांडली. ही डिटरमाइंड द रेशियो ऑफ द चार्ज. ही put forward the ratio of the charge to the mass of the cathode rays. He also discovered electron. त्याने इलेक्ट्रॉनचा सुद्धा शोध लावला. And in this way he discovered that the atom have an internal structure, and he discovered this in 1897. Next question is, what are the two parts of an atom? What are they made up of? Now this is very simple question. You know that atom is made of two parts. First part is its nucleus. In this nucleus, protons, positively charged protons, and neutral neutrons are present. And another part is the outer side of the nucleus. In this nucleus, in this outer part of the nucleus, electrons are present and which are negatively charged. या न्यूक्लियस मध्ये प्रोटॉन आणि न्यूट्रॉन असतात. The total mass of the atom is concentrated in the nucleus. याचं जे पूर्ण वस्तुमान असतं हे पूर्णपणे एकवटलेलं असतं त्याच्या केंद्रकामध्ये आणि केंद्रकामध्ये असतात प्रोटॉन आणि न्यूट्रॉन. Proton is made from the 3 quarks and neutron also made from the 3 quarks, and these are the orbits. Electrons are revolving in the orbit. So this is the structure of atom. You have already learned this in the last year in the 8th standard. So the size of the atom is determined by the radius. This is the radius. As we know in the geometry, there is a radius of circle which is denoted by r, and if we know the value of r, then we can decide how much bigger is the circle. जर आपल्याला रेडियस माहिती असेल तर आपल्याला समजतं की वर्तुळ किती मोठं असेल. सो सिमिलरली ॲटम इज ऑल्सो सर्क्युलर, त्याचा आकार सुद्धा वर्तुळासारखाच आहे. So here also the size of the atom is also determined the radius, which is called as the atomic radius. What is this atomic radius? It is the distance between the nucleus and the outermost orbit of the atom. If this is outermost orbit, then this is the atomic radius. If there is another orbit, then the radius will be this, the distance between the nucleus and the outermost orbit. In this way, the size of the atom can be determined by its atomic radius. In geometry, we calculate the radius or we denote it in the unit of centimeter. भूमितीमध्ये आपण जे एकक वापरतो आकृत्या काढताना ते असतं सेंटीमीटर. बट ॲज द ॲटम इज व्हेरी 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 स्मॉल, इट इज व्हेरी टायनी, सो देअर शुड बी स्पेशल युनिट विच इज कॉल्ड ॲज द नॅनोमीटर. This is the unit that we have to use to calculate or to show the atomic radius of any element. So here a picture of the atom of iridium element is shown in your textbook. You can see it. विद्यार्थी मित्रांनो, तुमच्या पुस्तकामध्ये ही जी आकृती दिलेली ही आकृती इरिडियम या एलिमेंटच्या ॲटमची, अँड धिस image is taken by the field ion microscope, which is very very strong and which is very very powerful. विद्यार्थी मित्रांनो, तुम्ही जी आकृती पाहिली ती इरिडियम मॉलिक्युलच्या ॲटमची आकृती आहे, which is taken by the field ion microscope. As we know that the atomic radius is measured in the nanometer, so we should know the relation between the meter and nanometer. So here is the relation between meter and nanometer. So 1 upon 10 raised to 9 meter is equal to 1 nanometer, and 1 meter is equal to 10 raised to 9 nanometer. So this is the relation between meter and nanometer. By this you can identify the how much small unit is this. So here we have some atomic radius of different atoms or molecules. So here the hydrogen atom which have the atomic radius 10 raised to minus 10 nanometer. The atomic radius of the H2O molecule is 10 raised to 9 nanometer, and the atomic radius of the hemoglobin molecule is the 10 raised to minus 8. So all these atomic radiuses are presented in the nanometer. So in this way we can find out the atomic radiuses of the different molecules by using very powerful microscope like field ion microscope, also scanning tunneling microscope and electron microscope. These are the some powerful microscope that are used to observe the image of the atom of any molecule. The atomic size depends on the number of electronic orbit of an atom. The greater the number of orbits, the larger the size. If the orbits are more, then larger is the size. या ठिकाणी जितके जास्त ऑर्बिट असणार तितका त्या अणूचा आकार हा मोठा असणार. If there are same orbits of the different molecules, suppose sodium and magnesium, the number of electrons in sodium are 11 and the number of electrons in magnesium are 12, and number of orbits are also same. In this situation, the element in which the number of electrons are more is have the smaller size of atom than the other element which have lesser electron. ज्यामध्ये कमी इलेक्ट्रॉन असतील त्याचा आकार जास्त इलेक्ट्रॉन असलेल्या मूलद्रव्याच्या अणूच्या आकारापेक्षा मोठा असतो. म्हणजेच काय तर सोडियमच्या अणूचा आकार हा मोठा असणार कशापेक्षा, मॅग्नेशियमच्या अणूच्या आकारापेक्षा. तर विद्यार्थी मित्रांनो, आजच्या तासामध्ये या ठिकाणी आपण थांबूया. पुन्हा भेटूया पुढच्या मुद्द्यासहित. धन्यवाद.